Russell Gardner, and the science experiment that I'm going to conduct for this week's project is going to be on making a battery out of a tomato. The reason I chose making a battery out of a tomato was because I work around aircraft and everything else was making slime or playing with chemicals around the house, and honestly none of it appealed to me. So what really worked for me was something about making a battery, because when you work around aircraft and electricity, making a battery just felt natural. So as I was looking around the house, I realized I didn't want to use up what I did have for tomato paste, and I was trying to find something acidic, because the way a tomato battery works is you have two dissimilar metals in an acidic base, and then the positive charge, the reaction will go from through the juice towards the positive, because negative will always go to positive in electricity. So what I chose was apple cider vinegar. Now, if you can see what I have here in front of me, I have a penny older than 1982 because of its copper content, and I've got it in a cotter pin, just a large clip. And then on the other end, I have a galvanized steel nail, and then the wire itself is galvanized steel. So what I did is I put it in a little glass dish with the penny and then the galvanized steel, and I put it in the apple cider vinegar. And what I want to show you is how the digital multimeter will actually read electricity coming from the exchange of the electrons in the vinegar solution. So if you look at my leads, I'll put them straight into the liquid, and there is actually very little stray voltage. It's actually in the water. We didn't have that yesterday. It's kind of neat. So I'll take the positive, and I will put the positive on the copper, and I will put the negative on the steel, and you will see that I have a 0.6 volts DC, almost 0.7, and it looks like my polarity was reversed. Right there. Actually, it still says it's negative. There you go. 7.7 volts DC. So what I'll try to do now is set up another one in series. But interestingly enough, if you look at this one, the penny actually corroded, and the cotter pin that's holding it corroded overnight from the acidic solution in the vinegar. I thought that was kind of neat, because that looks pretty bad actually. So what I'm going to do is I'm going to take a second battery. I'm going to add my apple cider vinegar so that I have my acidic solution. And then, of course, it'll react with the metal, and then it's going to flow from the negative to the positive through the copper. So I'm going to take my steel from that solution and put my penny in that solution, add a little more, just to submerge the copper. And then I'm going to take this steel nail and put it in there. So now what I have is negative to negative to positive. So it's a big loop, and that makes it a series. Right? If you can see the meter, I've got the leads together, and I've got 0 volts direct current. I'm going to put my lead on the negative on this side and the positive on this side. And I actually have 0.1, so not the strongest of connections, but I will go here to here, positive to negative, not as strong, and then we'll put it in this one again. And this one is 0.5. Now what you'll see, these two, this penny and this solution has been soaking overnight. The solution that I just started has not developed a big enough charge yet because it hasn't been soaking long enough. So I've got positive to negative, and now I have a 0.1. 0.1, almost 0.2 at times. So it's building. The charge is actually building. And then I go to the other side, and I have currently a 0.3 volts DC. So I'll try once again to go through the solution and through the wire, and now I have a 0.12 volts direct current. And that's going through in series through the negative of the steel to the positive of the copper, through my steel wire to the negative of the steel to the positive of the copper. And in aircraft wiring, what we do is we call it continuity, which means that it's continuous. If you check on the meter, that means I have continuity. It's a continuous circuit. So if I put it on my negative on this side of the dish and my positive on this side of the dish, I'm actually reading 0.79. So it's reading as if it's a resistor or a diode. But I go over here to the other dish. Here, we'll do that again so you can see.